Hi guys, David Kay here. I'm a long-time Rhino user. Well, I say about 10 years now. I think possibly 2012, 2013 was when I first got started in the software. My full-time job is a product developer in the water sports industry, primarily kite surfing equipment. So I design and have manufactured anything that's hardware related in the kiteboarding industry. So that could be boards, bindings, control systems like our control bars, quick releases, all manner of different hardware equipment. And I've also been the developer of a plugin for Rhino specifically for designing kites. For this video today, Kyle from McNeil has been very kind to send me through one of his models. Kyle's actually been quite a large influence on my career, which I'm always very proud to tell people. I actually got started in using Rhino because of one of Kyle's videos. In fact, he was at one time using a Rhino plugin called T-Splines, which has been sort of superseded in recent years with sub-D built directly into Rhino 7 and now Rhino 8. But yeah, way back in the day, Kyle was doing training videos with T-Splines and sort of teaching people the fundamentals of that sub-D workflow within Rhino. And prior to seeing his videos, I was using other software for my design process, but there was something about that sub-D workflow, or sub-D with NURBS workflow, that really aligned with the sort of work that I do. And what I sort of tell people is, like, most of my work seems to involve some sort of smooth organic bodywork combined with mechanical hard points, or mechanical or sort of more traditional NURBS objects inside of some sort of smooth bodywork. And that sub-D, or previously T-Splines and now sub-D and Rhino, just lends itself really well to the to be able to design and model those type of objects in one software package. Now, recently Kyle's done a video on this game controller, and he's been kind enough to send me through this his sample or example file for it. And this is very much along the lines of the sort of work that I do. And in recent years, I've been taken to using Grasshopper to actually enhance this workflow. And it seems it's quite a strange thing with Grasshopper that there seems to be a lot of information available, a lot of training available for using Grasshopper for some of its more powerful paradigms, particularly in architecture, doing lots of very computationally intensive patterning. I think it gets used quite a bit for doing very complicated facades on buildings, and that or seems to be its sort of killer application in those industries. But there hasn't been a lot of instructional videos on how Grasshopper can actually be used to enhance a more traditional, or a more product development style of workflow. So before we get started on Kyle's model here, when trying to explain Grasshopper and my Grasshopper workflow to new designers, I have my own little Hello World program that I take them through, and we probably should just do that before we dive into Kyle's model. So a classic sort of Rhino modeling workflow might be something along the lines of this, where we can create solid objects. Let's go to a shaded view here, say a box, and a sphere, and we have these two objects in our in Rhino, and we can do something very simple with these. We can intersect them with each other, and let's say click one, solid, Boolean difference, and click the sphere. And we accept that, and now we have the resulting object of that sort of intersection and Boolean operation. Very standard sort of workflow. Create objects and then do Booleans between them to create the final object that you're looking for. The restriction in this workflow, or what sort of tends to slow people down in this within Rhino when you're looking at this, is that this now that we've done that Boolean operation, we've actually lost our source code, or we've lost the objects that we started off with. And the only way, like let's say we didn't like this detail here, the only way to change it is to click back. So reverse that operation, move our sphere a little bit, and then repeat our Boolean difference operation. And now we can see the result of that new operation. This workflow tends to work okay right at the beginning of a design, but as your designs get more complicated and you get more and more objects that have had operations applied on them, your chances of being able to reverse back through your operations to do a small change and then do those operations again just gets exponentially more difficult, or just so time consuming that you just cannot make changes. So one of the ways to overcome that might be you can put the objects off to their own layers. So now we've got those objects on their own layers. We can make a copy of those, put the copies into our working folder, turn off the others. We can then do our Boolean operation. And we still have our original objects available if we need to go back and do that operation again. Again, that workflow works okay, but as you start to chain more and more operations together, that could just get potentially just so massive that you're unable to effectively make changes over time. And as we know, as product developers, our customers always want changes done. So if your models become so complex that you cannot go back and make changes effectively, or that it becomes time consuming to do those, your effectiveness as a product designer can actually suffer. And this is where the likes of SolidWorks or Fusion 360, with their concepts of a history tree, where each of these operations that you do are recorded in a timeline, and you get along the bottom of the screen, and you can go back and find that operation and do a change before you do the Boolean, has become quite a prevalent thing that anyone who's involved in or has got into that style of modeling, where you have a history of what you've done, will find the direct modeling approach in Rhino quite restrictive when it comes to being able to do ongoing changes to your design. So Grasshopper, which we'll just open up now, is I think 15 years Grasshopper's been in development or within Rhino. So I'll just bring this onto our screen here. Grasshopper, when David Rutten at McNeil first started developing it, was actually called Implicit History, and I actually kind of like that name. I think for many for many product developers, the concept of thinking of Grasshopper not as a way of creating these fancy computational designs, but more as a way of creating a history tree type paradigm within Rhino is one that's just not well known and not well utilized. So with Grasshopper, we can actually take this concept, and I'm just going to turn our two objects back on, and I'm going to pull them apart from each other. We can take these two objects, and rather than doing a destructive Boolean operation where we lose those source objects, we can create a script that, what I like to call, just creates a relationship between these objects. So first thing to do is we open up Grasshopper, and we first need to pull the source objects into our Grasshopper definition. So the easiest way to do that is double click on the screen, and for sort of general purpose geometry, a geo or geometry object is a good way of pulling in objects from Rhino. So I'll bring up this geometry object, which we can also get to via this geometry pull down in the first screen. We come down to here. We have all of these different primitive types, but right down the bottom here, geometry just contains generic geometry. So I've pulled up that geometry object. I can now, what I'll do is I'll right button mouse click on it. I'm going to change its name to box, and then click on this set one geometry, which I can now click on the box. And now if I turn off that box layer, we actually have this we have a ghosted object in our Rhino environment, which is actually this box in the Grasshopper environment. So that's the first one. And the second one, I'm just, again, a geometry icon, and a right button mouse click, and it's just always good practice to rename these to something that describes what you're pulling in from your Rhino environment. I'm just going to set one geometry again, and now I can turn off the layer. So I now have these two ghosts. They're not clickable. So these now exist purely in our Grasshopper environment, but we now have these objects sitting in port into Grasshopper. Now I'm going to turn on my two Rhino objects, and maybe to make this a little less confusing, I'm just going to change the color of that layer. So I'm going to grab my sphere and just move it so it intersects with my box. Right, now we can turn off these two layers again. So now we're just, the preview we're looking at on the screen is just the object sitting in our Grasshopper. And I would like to do a Boolean operation. So I can double click here, and if I type difference, there is a solid difference. So I'm going to take my box, and I'm going to take the sphere away from my box. Now this operation has been successful, but we can't really see what's going on because these two objects are intersecting with each other. One of the things we can do is we could click the two input objects, and we can turn the preview off, which allows us to see now the only thing that's visible in our Rhino environment is actually the result of this Boolean operation. Now this is the powerful side of Grasshopper, is we're actually, what we haven't done is we still have our box, we still have our sphere, but we now have a third object in Grasshopper, which is the difference between those two, or the box minus the sphere. So this object So all three objects still exist. And if we turn this preview back on, we can turn on our two source objects, move the sphere, turn off the layers of the two source objects, and then this this relationship between the two of them, because these are live linked, these two objects are live linked back into our Grasshopper environment. Any changes we do on the Rhino objects, the Grasshopper will script will automatically update. But one of the things here is we can't really see the result of our operation when they sit on top of each other. So to make this a little more useful, I'm going to type move and bring in a move component. And if we look at our axes here, I'd like to move my preview along the y-axis. So I can bring in a direction, which is a unit of y, and I'm going to try 50. If I just type 50 millimeters, I get this slider. This allows me to put in different values. I'm just going to plug this into here, and 30 is not really enough. 100 was barely enough. So I'm going to edit this and take our max to 500. And now we can move this object. Now I'm going to turn off preview of everything else. And now the only thing that ghosted object we can see in our Rhino environment is actually this last one, which is we still have. I turn off my Rhino objects and turn preview on. We still have the box, we still have the sphere, we still have the difference between them, and now there is another object which is actually this difference moved 191 millimeters along the Y, and this is the only one that we actually have on a live preview now. So now that we've got that set up, we now have the ability to do very, very fine. I'm just going to move this across a little bit further. We now have the ability to see our resulting object and move our input or make changes on our input objects and see the results live. And maybe we want to do something like we can scale the sphere down, and maybe that's one of the objects we're happy with, and we want to make a Rhino copy of that. If we right click on our move here and go to bake, and we'll just put this out to the default layer, we now have that object existing as a Rhino object, and we can scale this back up a little bit, move it in a little bit further. Maybe that's not quite what we were looking for. All right, and then we can bake that version out. Or maybe our client actually wants the reverse operation. So we could put down another solid difference operation, but this time we're going to take the sphere away from the box, and we plug this into here. We'll take the box away from the sphere. We'll actually end up with this object, which is the reverse of what we were originally looking at. We can bake that out, and that will actually be two objects because we ended up with a little extra piece. But in the space of just a minute or two of setting up this Grasshopper definition, we're now able to make many different iterations with very, very fine adjustment by by having this and live preview of what we're looking at. So that is really, that's, if there's no other paradigm that or no other thing that you would use Grasshopper for as a product designer, I'd highly encourage you just to use it for what I'm using here, just as the ability to do sort of Boolean type operations, but with live previews and the ability to do sort of fast iteration on your objects. So that's my hello world. But like a lot of these things, like unless you see it as a practical application, this might not make so much sense. So I'm just going to open up here this and go through one of my more simple sort of office work or paid work applications that I would use this workflow for. So I have a thing where I need to make a washer, and it needs an M16 screw, and they need to be on a 38mm center to center, but it's a little symmetrical object. Now this is the sub D bodywork that this washer is going to be based on, but we have this is the sort of screw object that the customer wants this washer to work with. And so I downloaded this model from actually from MasterCard, which is a very handy place to get 3D models of the likes of fasteners. So that's the screw we're going to be using, and from that screw I created this solid object which would provide the clearance for that screw. So if we go to a ghosted view and turn the screw back on, and this just provides all of the space needed for that screw to bolt on. So I'm going to launch my Grasshopper. Pull that onto the screen here. So the first thing I'm going to do is pull in my my clearance object. So we'll call it clearance, and we'll set one geometry, and we know we need two of these. Now this one's sitting on the origin, and it's actually at the right height, but our fin space or our bolt spacing is 38mm. So I'm going to put a slider of 19mm, and I'm going to type move, but we actually want to move in the X direction, unit X of 19mm, our clearance, and we also need to mirror this object. So we can mirror this, and that's actually brought up the right axis, the YZ axis, but I'm going to bring up the YZ plane again. So now we turn off our clearance solid. I'm going to put a little geometry here so that we can see these two objects together, and we'll preview those off. So now we have our two clearance objects are actually arranged at this at the 38mm apart, but sort of both 19mm from the center. We also can do the same with our screws object. So turn on our screws, and we'll rename this screw, and we'll set one geometry, turn this off, and we can move, we copy that move object and turn the preview on. We've now moved that the same direction as the other object. We can also, rather than do a mirror, we can take this Z, create a negative, and move the object the other way. So turn off all these other previews, and now we actually have the screws sitting in their appropriate clearances. So I'm just going to create a geometry here to combine these two objects into a single selectable, and preview this off. So there is our screws in the right position, but again, once we put a bodywork in here, it's going to be kind of hard to see what's going on. So again, I'd prefer my screws to be sitting off to the side so that I can use them in the resulting in the result of this operation. So I'm going to type move again, and if I just hold down Shift Control, I can grab these wires and bring them onto this move object, and we want to go in the Y direction this time. And I'm going to put 50. 50 is probably further than we need to go. Let's make it 30 millimeters. Alright, so the screws are now sitting off to the side. That has pretty much got us prepped. I don't really need to see my clearances at the moment, so I'm going to preview those off. I just want to see these screws. And sometimes this ghosted view I find a little difficult to see detail when we're actually coming to start working on our sub D. So we can go up here to display, down to preview settings, and I like grabbing this this dark grey we can put onto here, or maybe even go a little darker. We'll start with a dark grey and see how that pans out. But that and also under, if we have a look here, this particular colour, so where the previous colour was had some but on the off it was quite light on the off channel, it was quite see-through. We'll make it solid. That gives us a better I find just gives a better view of what's going on when we start using this or adjusting the sub D. So finally, what we need to do is bring the sub D body in, and we see that this is open on the bottom. But we can come here, we can go sub D, and you really need to bring a sub D model in using the sub D type. So we'll just call this body, and we can set one sub D, and I'll turn that off here. So the first, because this is open from the bottom, and I really need this as a solid object, the first thing I'm going to do is a cap. So we now have a solid object coming out of here, a closed B-rep. And that, because we have a closed B-rep, and up here we have our these two clearance objects, I can do a solid difference operation. So I want for the solid difference, there is my capped sub D. Would actually be a B rep now, and I can bring down these two clearance objects, and the result of that operation is we now have our bolt mounting holes in this object, but again, this will be sitting in the same location as our sub D, so rather hard to actually see the results of this. So what we're going to do is we're going to take that same move operation that we did previously. I'm just going to take a copy of it and wire in our sub D. Our sub D now moves to the same location as our bolt holes. And if we turn this preview off, or preview on, and we turn off our other previews, we now have the setup where we can actually see, turn this preview off as well, where now we have the resulting object that's our sub D minus the clearance for the bolts, and then with the bolts or screws in their correct locations. Now, a few minutes to set that up, but now we have the ability, we can turn on our sub D object, and if I go to the top view, this sub D has two symmetry planes, one on the x-axis and one on the y-axis. And if I go to our boxy view, and I'll turn on sub-object selection, maybe we want to change the shape of this internal hole. I can now grab this, say this control point, move it up a little bit, and maybe grab this set of this line here. And if we watch our final object, as we move this shape will change in this shape will change live for us, so we can see the result of our changes. And where this can be particularly useful is if we're trying to get, now I've done some work on this, if we're trying to get the shape of this sub D to match nicely with the shape of the screws, we can do all of those changes within our model here, and watch everything update in the final version with all the booleans, everything done as an operation, but not actually but something that can be done over and over again. Now, once we're happy with the shape, it's simply a matter of coming in here, and we can select that object and bake it out. So I'll turn off this object, and we go to monochrome view, and there we go. That's that is our final washer object. Okay, so that's so we've gone through sort of my hello world, and then into what I would describe as a real world application of this workflow. Let's have a look at Kyle's model and what how I would set this up as to use that same workflow. So I'm going to turn off sort of Kyle's final object here. Now what I have done here is I've gone through and sort of split that model back up into all of its constituent parts. So we have the sub D here with its symmetry plane in the middle, and then there are these sort of left and right button plinths. Now rather than use both of these, I think I would be more inclined to use a single one. So I'm going to take a copy of this and go to my box edit, and in our front view we'll set this position to this X position to 0, so we've got it in the center, and I'm just going to hide the other two for the moment. Now we'll open our Grasshopper, and same workflow as before. The first thing I want to pull in here is our bodywork. So let's go to the sub D, and I'll turn off these buttons. So I'm going to click sub D, and set one sub D, and then we'll turn that off, and then I'm going to pull in this first button. So or button this. It's really the button mount. And we want to do a union. So we have this, and we have this, and check here, we have one closed B-rep out of the end of it. So I'm just going to again turn off our source object here. We'll go to just selected preview. So we'll go to our front view, and I'm going to turn on, I'm going to unhide the actual location of this of the other object. I'm just going to pull this over until I'm approximately the same position as where the previous one was, and we shall hide that, and we put a mirror here. We now have both. We've got both of those objects are now in a, or both of those button mounts are now unioned with our sub D, and it'll be the same again here with our joystick mounts. We'll probably take the left one again, or our joysticks itself. So we'll take this, I'm going to create another geometry object. I'm going to call it the joystick, and I'm going to set one geometry, and I'm going to do a mirror operation on this, and I'm going to do a second solid union operation because this, if we have a look here, because this joystick overlaps with the button mount position, it's I'd prefer to, I'm going to union, I'm not going to do it as a single union operation, I'm going to do it as a second union operation, but we can do it with all three of those objects. So we can now turn off our preview here, and so now we have the button mount position as a mirrored object, the joysticks as a mirrored object, but I want to shift this probably in the x-axis. I want this my preview sitting off to the right hand side here. So I'm going to put in a move object, and I'm going to put in X, and Kyle being an American friend of ours, of course everything in here is in inches, so I'm going to actually going to make my life a little bit easier. I'm going to change my unit settings. I'm going to change my unit settings to millimeters, and those units are okay, and yes. Oh, I liked it. And I'm going to resize everything to be in millimeters. So we'll check the size of our bodywork. So we're about 130 millimeters. So if I put 150 in here, move and go have a look. There we go. Now we have our preview sitting off to the side of everything else. I'm going to turn off all of our other previews, and I'm going to go to my display and preview settings. I'm going to pull in this this dark one, and now we have this object sitting in our Rhino. This object sitting in our Rhino viewport, which is actually the Boolean of all of our input objects. And the only thing we haven't finished off with here is actually our the buttons that would go on each of these mounts. So we can do that. I'm just going to pull this over a little bit, and go back to our layers, and I'm going to turn off the bodywork, and I'm going to turn on, we have these square buttons, which are these are solids that that are sitting somewhat where this mount is. So I'm going to grab these, and in here put in a geometry and go set multiple geometries, and I'm going to rename that square buttons, and these are basically sitting in the right place at the moment. So I want to do another solid union, and the solid union with the square buttons, and I want to replace this in my preview. So now if we zoom into here, we now have an object that actually has those square buttons placed in the on the right, well, on our model. And if we do something, we can move these a little bit, and we'll see it live update. But you would probably create these to be always concentric with their mounts, but that's sort of beyond what we need to do in this video. So that's set up, and then the one last thing that we need on here is these the round buttons, which are these ones here. So same again, create a geometry, rename it round buttons, select these objects and go set multiple geometries, and then we can quite simply with those, I think we're fine. We can just wire it into this union and just check here. We have one closed B-rep out the end of it. So I'm going to turn off all of my turn off all of this geometry, turn off my previews, except for my last one. And now what we have here is a live preview of everything that we're doing in our Grasshopper, with our Grasshopper script, with our input objects. And a little trick here, if you want to zoom to this object in your Rhino viewport, if you center mouse click and click this icon, it will now be your Rhino environment will actually be centered, or your Rhino zoom will be centered around that Grasshopper object. Off it. So now let's have some fun with this. If I'm going to turn my joystick object on. So this is the one that we're actually using in our Grasshopper script. If I move this a few millimeters sideways, this live updates on my on my Grasshopper script, and we can, let's say I don't really want this hanging off the bottom how this is going. I can grab this and just move it up a few millimeters until we see how it fits in this sub D. Maybe just a little bit more. So, and we see that's not impacting on our button mounts or anything like that. Our button mounts are fitting really nicely. So that's really how you would set this up. Like you can now iterate through all of your input objects. So your bodywork, your joystick, the different buttons, these can be replaced with other items. My OCD says I want to rotate these objects to be, I'll turn my ortho off, rotate these objects to be a little more vertical. All of that side of things can all be done, and you do not lose any of your input objects. These are all separate things. They can all be amended. You can do things like scale this joystick down to make it a little bit smaller. All of it just happens live in your thanks to your Grasshopper script. And finally, once you've got it to where you want it to, you can bake this out. It'll take a couple of minutes, or a couple of seconds I should say. And once that is, we have a problem here. That's a closed B-rep. That's a closed B-rep. Aha! No, it was just a very complicated render mesh that had to get done there. So I'm just going to turn off my preview in Grasshopper. And now what we have is a completely one closed poly surface, which is the combination of all of our objects,
and yeah, that any further processing that needs to be done can be done in your Rhino environment. So thanks very much, guys, for listening. I don't know how long this has run, but I hope you found it useful. And Kyle, thanks again for all your fine work in uh, showing or doing these videos for us on on how to use Rhino and all these great tools. And I was able to maybe teach you something about how to combine Grasshopper with these workflows. Thanks very much.